when we were talking before with multiplying powers or the product of powers, if they had identical bases, we would add the exponents. If it was a quotient of powers and they had identical bases, we subtracted the exponents. Now we're talking about a power of a power. So, for example, we might have a problem like the following. If we have 4 to the second power, or 4 squared, and then we're raising that to the third power. This is called a power of a power. So you're taking a base and exponent and raising it to another exponent, a second or a third or a fourth exponent. So ideally how this would be written down is this value right here is repetitive multiplication by 3. So we would be breaking this up into 4 to the second power times 4 to the second power times 4 to the second power, because of the fact that that third power is telling you to take what's inside parentheses and do that repetitive multiplication 3 times. Well, we already know that if we multiply by the same base, then what are we going to do with those exponents? Add them. So we're technically adding those exponents and keeping the base the same, so it's 4 to the 6th power. Well, if we're looking at what the original problem was and looking at what our resulting answer is, what are we technically doing here, Heaven? Multiplying the exponents. Is the base changing? No. The base is remaining the same. It's the exponents that are getting multiplied together. Okay, so here's our rule. When one base has multiple exponents, you're going to multiply the exponents. And keep the base. And that's a very important thing to remember, is that you're keeping that base. Okay? So if we've got something, yes? That you're only multiplying the exponents? That's perfect. I think that's a great idea. That you're only going to be multiplying the exponents. You're going to multiply those exponents. Okay? So if we had a problem like y to the third to the fourth, what would that give us? Y to the 12th. Okay, so we're keeping the y just as it is, but we're taking those two exponents and we're multiplying them. It's 3 times the 4, which is going to give us y to the 12th power. So I'm going to have you guys just do a couple of these on your own, because this is the easy part. Shh. Shh. Quiet.
Wait, is there a power of a power of a power?
Mm-hmm.
A power of a, so you just multiply them all together?
Mm-hmm.
Oh, Superman's ice, because the fact that this is black.
No, you're going to leave it in its pi format.
That's a lot of damage.
That's a lot of talking after I've asked you not to.
You know Miss White?
How are you supposed to multiply pi?
I told you to keep it in its pi format. Shh. You guys are getting way too loud. All right, who can raise their hand and tell me what they got for number 3? Annalise? Pi to the power of 30. Very good. So all you're going to be doing is you're keeping pi as it is, and you're just multiplying the exponents. 5 times 2 times 3, and that's going to give you pi to the 30th power.
Can I ask
Okay?
the third one? I mean the fourth one.
Go ahead, Arham.
It's m to the 9th power.
M to the 9th power is correct. Okay, so again, all you're going to be doing is keeping the base the same, and it's going to become 3 times 3 for the exponent. You get m to the 9th power. Okay, and then for problem number 5, Akshaya, v to the 12th power. So you keep the v just as it is, and you multiply the 6 times the 2, and that's going to give you v to the 12th power. Okay, so that's the easy part. Now let me go ahead and get into the stuff that's a little bit more difficult. If you had a problem like the following, we've got, well, I'm just going to go ahead and rip the Band-Aid right off. We've got 5r to the 4th, x to the 10th, to the 4th power. So for a problem like this, where you have more than one base that is inside the parentheses, and you have the exponent outside the parentheses, then what you're actually doing here is, it's almost like it's, so you've got this product that's happening, and like I showed you before, up here, hey, whatever was in the parentheses, it's repetitive multiplication. It's the same thing for down here. This means it's 5r to the 4th x to the 10th times 5r to the 4th x to the 10th times 5r to the 4th x to the 10th times 5r to the 4th x to the 10th. However, instead of having to write all that out, what's really occurring here is you're taking this exponent and you're going to distribute to each exponent inside the parentheses. Now here's the part where everybody always messes up. They skip over distributing it to the 5, because the fact that the 5 doesn't have an exponent written, they automatically assume there isn't an exponent. But what do we know?
Everything has an exponent.
Everything always has an exponent. If the exponent isn't written, then it means it has an exponent of a 1. So I'm going to write that in there. So what we do first, we're going to focus on the 5. We're going to distribute the 5 to the first with the exponent of the 4. So that means that this is going to become 5 to the first times 4 power. Well, what's the first power times the 4th power? 4. So this becomes 5 to the 4th power, and then we can actually do 5 to the 4th. What does 5 to the 4th equal? 625. Okay, we do 5 times 5 times 5 times 5, 625. Okay, we move on to the r to the 4th. We're taking r to the 4th and we're going to multiply it by the exponent of 4. So that means this is going to become r to the 4 times 4 power. What is that going to give us? R to the 16th power. Okay, then we're going to do x to the 10th. So we're going to multiply that by the 4th. So that means it's x to the 10 times 4 power. So what is that? X to the 40th. Okay, so now all we have to do is just combine that all together, and that's our final answer. So our final answer is 625, r to the 16th, x to the 40th. Yeah. That's why we're going to keep doing multiple problems. Because the only way that you guys will understand it is by repeatedly doing it. It's kind of like a skills and drill. But while you're copying it down, let me go over it one more time. Shh. When you have an exponent outside the parentheses and you've got a product of exponents inside parentheses, then all you're going to be doing is distributing that exponent to each exponent on the inside. Remember, distributive property means multiplication. The distributive property means you multiply whatever is outside to each component inside. That's the definition of distributive property. So you're distributing that exponent to each exponent inside here. The base doesn't change. R stays R, X stays X. Technically 5 stays 5, but we know how to simplify that. Okay, so this becomes 5 to the 4th power because 1 times 4 is 4. But then we can simplify 5 to the 4th to 625. R is going to become r to the 16th power because we take r's original exponent of 4 and multiply it by that outside exponent of 4. X becomes x to the 40th because we take the original exponent of 10 and multiply it by that outside exponent of 4. And then all we do is just push it all together. Okay, so let's take a look at another example. What problem was that? 6. All right, so here's problem number 7. Okay, we have 7 to the 2nd, a to the 5th, b to the 6th. All of that is going to be raised to the 4th power. So break it down piece by piece. Let's start with 7 to the 2nd power. We're going to distribute this 4 that's on the outside to each individual exponent. So 7 to the 2nd is now going to become 7 to the what? 8th power, right? Because we're going to do 2 times 4. That becomes 7 to the 8th power, which will become what? What's 7 to the 8th power?
5,764,801.
Good. So 5,764,801. Okay, then we move on to a to the 5th. So that a to the 5th is now going to become what? Jordan? A to the 20th, because we're going to multiply the 5 times the 4, and that's going to give us a to the 20th power. All right? B to the 6 is now going to become what? Nathan? B to the 24th, because we're going to do 6 times that 4, and that's going to give us b to the 24th. And then that's it. That's your final answer. I'll just write it all in one color so that you can see it's all together. So 5,764,801, a to the 20th, b to the 24th. What's the very first thing that I should do here? Ian?
The exponent of 1 to the -2.
Very good. Put an exponent of a 1 to that -2. Now what do I do? Akshaya?
Distribute the 6 to all the other exponents.
Very good. We're going to distribute that 6 to each of the other exponents. So what does -2 become? What's the new power going to be? Colin? -2 to the 6. What's really important about how I write that, though? Parentheses. I have to put that in parentheses. Why?
It's negative.
Because it's negative. And I need to include that negative. So that -2 was originally written to the first, but I'm going to multiply that power by a 6, and it now becomes -2 in parentheses to the 6th power. And what is -2 in parentheses to the 6th power going to give us, Jordan? Joshua? Very good. It's going to become 64 positive. Now please note that if you forget to put parentheses around that -2, and you just type in -2 to the 6th power, it's going to give you a -64 if you forget to put the parentheses. Now, for, I don't think that it'll do that with, let's see here. The nice thing with the black calculators, you don't have to write the parentheses. But with the yellow or the XS calculators, you do have to put the parentheses. If you don't, like if I just do it as -2 to the 6th power, it's going to give me a -64. How do I do the negative? The negative sign's down here at the bottom. The exponent is that little arrow. No, the subtraction sign is going to give you something different.
That's why you put the parentheses, because that's what's. So you can also get an exponent with an x to the same.
No. Guys, look, if you use the subtraction sign, you're going to get an error. If you use the subtraction sign as a negative, you're going to get an error. Take a look. If I put a parentheses and I put a subtraction sign, so I hit subtract and then the 6 and close parentheses, and I want to put it to the 2nd power, it's going to give me syntax error because you cannot use, and it'll, once you hit clear, it's going to show you where the error is. See how it's flashing over that minus sign? It's letting you know, hey, you can't put that minus sign, it has to be a negative sign instead. Then you hit enter and it'll give you the proper answer. You cannot use that subtraction sign. Those of you who think that you can, I don't know how you're getting away with it. Unless you're doing 0 minus 6 to get a negative, which is, fruitless, but you can't do that. Yes? If you're trying to include that negative, so if the negative is raised to a power, you have to put the negative inside parentheses. Okay? Same thing with a fraction. If a fraction's being raised to a power, you have to put the fraction inside the parentheses and the exponent goes on the outside. All right, let's take a look at the a to the 2nd. Who can raise their hand and tell me what is a to the 2nd going to become? Colin? A to the 12th, good. Because we're going to take the 2 and we're going to multiply it by a 6, and that gives you a to the 12th power. What about b to the 7th? What will b to the 7th become, Kendall? B to the 42nd power. Can't say B 42. Okay? So you're distributing, so it's B to the 7th times the 6th, which becomes B to the 42nd power. Okay, so then that's it. That's your final answer. If you piece it all together, it's 64, A to the 12th, B to the 42nd. Lena?